Good afternoon, everybody. Today, the topic given to me is electrical safety at the homes. To practice electrical safety, either in an industry or anywhere, it is better to start study from our home premises itself. Today, in our day-to-day life, we know we have changed a lot. From the conventional household appliances, now we can't live without electrical appliances such as induction cooker, fridge, mixie, grinder, mobile, or iron box, or etc. etc. Now, electricity. What is actually electricity? Electricity is as dangerous as it is useful. These are the basic definitions. Unlike other products we use every day, we can't see, hear, or smell electricity. So we may not always think about using it safely. A carelessness or a piece of faulty equipment can cause an electrical accident. Minor electrical shocks could be fatal, and minor errors while handling electrical equipment could hurt you. The more we learn about the safe use of electricity, the less our chance of injury. Electricity gives us light, but do not take electricity lightly. Actually, the unseen electricity must be handled very carefully. Otherwise, we may face fatalities and injuries. So handle them very carefully, for which we must understand the safety points based upon which electricity need to be handled. Let us see the record from National Crime Records Bureau of India. As per this record, about more than 30 fatal accidents, electrical accidents are occurring in India per day. See, it is a large number, Now let us see the status in our state. What is the status in our state? See here, about 210 human died from 1/4/22 to 31/3/23. It is really very pathetic. But comparatively, the rate of electrical accidents are getting reduced due to the statewide effective safety awareness that we are giving and due to effective implementation of electrical safety guidelines. And now let us see the causes. Here it is important to note that majority of the accidents took place in consumer premises and to the common public. See here, consumer premises 112 and to the public it is 182. Out of this, snapping of conductor and due to the use of metal rod and ladders near electric lines are in the high end. See here, rod using iron rod and ladder, then the snapping of conductor. These are in the higher end. Now, I am showing you some accidents, paper cuttings. We should get an idea about electrical accidents. Here, this person was repairing a washing machine. And here he was, this fellow was clearing the plants near earth pitch. Accidentally, he got shocked through the broken earth wire, which can carry a return current that caused his death. Similarly, in this case, due to the temporary non-standard wiring while the boy was handling the small electric motor of the aquarium, he got electrocuted. It was happened during construction of his house. Okay. Now let us see another this accidents, and here are some other recent accidents. Here, this guy was climbing a coconut tree, but part of the tree was touching the nearby electric line. And here in this case, he was also repairing a washing machine. See here, actually it is not a recent one. This lady got electrocuted from the earth wire, which was broken when she was clearing his front side of her home. Then in this case, she was handling the charger of a torch which caused electric shock. Actually, it was not the original charger of the torch. And in this case, the 3-year-old child was getting electric shock while he was trying to put on the TV. From the plug, he got electric shock, and during that time, it was raining and lightning. Now, I am showing you some examples of electrical accidents. Actually, I listed these things from my own experience. Just I will explain here and there, not in detail, examples of electrical accidents in residential premises. From earth wire, I have shown you some examples. Then while operating and repairing these electrical appliances, iron box, mixie, TV, etc. Then while plucking jackfruit, coconut or mango using metal or iron rod and near electric lines. See, I am showing the examples of electrical accidents happened to our residence area or near to our house or inside the house. Okay. While working through metal ladder means it will not be insulated. See, I like to give an example. I faced an inquiry regarding this item. See, house was painting, and the painter was painting a portion of the building which was below the EST line. You know, EST line means it is not necessary to touch the line to get electric shock. By induction, it will be getting electric shock, and the painter died due to this EST line. An EST line coming in contact with that ladder. Then snapped electric lines, then temporary wiring during construction of houses, then from damaged service wires. Because I like to give you an example. There was an accident in Changanasheri, Kottayam, for which I was conducting the inquiry. There was a joint or a strand coming out from the service wire, and it was touching the support wire, or we call it as guy wire of the service wire. This guy wire was connected to a truss work, GI truss work of that house, and a girl belonging to that house got electrocuted touching that truss work. Then through metal made clothesline, or we call it as saga. In Malayalam we call it as saga. See, this clothesline will be, one end of the clothesline will be connected to electric post, or it may be, actually it is a metal made and it may be touching some temporary wiring or joint live wire, it may be. See, I faced 2-3 incidents belong to this category. Then when changing electric bulb, actually, when you are changing the electric bulb, you should off the supply. Then children playing near electric lines or flying kites near electric lines. Then when doing priming of water, I think 3 years back, there was such an accident happened in Kottayam during priming of water pump. Then while operating faulty main switch, actually there is an ebonite rod, it should be an insulator, but due to the aging, it got complained and it was conducting electricity, and while operating the main switch, he got electric water. Okay. Now let us see what is electricity. To study electric safety, we should study what is electricity and some basic terms. We heard about various types of electrical accidents happen. For us to be safe and to understand about safety handling of electricity, we need to understand some basics about electricity, such as what is really electricity and how it is felt and how it is measured, etc. See, here water stored in this tank, and it will be flowing downward when we open the tap, and means water moved from one place to another place. So in physics we call a work is happened here due to the change of displacement of water. So the water stored in this tank was having a potential energy. When we opened this tap, it was coming down by conversion of the potential energy to kinetic energy. Here I like to tell you a word, potential. Water stored in a height will have potential energy. This potential caused the movement of water. A similar word is there for electricity also, which is called the same word, potential, or we call it as voltage. This voltage or potential, we can say it as the cause of electric current. If there is a voltage or accumulation of electric charge, see, I am replacing water with electric charge. So accumulation of electric charge means there is an voltage. And this voltage, this higher voltage will cause a flow of current. Okay. Now, when we create a path for the electric charge to flow, a current will be happened and this bulb will be flowing. Here you must understand a point that water is flowing from higher point to a lower point, or from a higher potential to a lower potential. Likewise, current will be flowing from a higher potential point to a lower potential. Or simply, current flows from high voltage point to a low voltage point. Means current will be flowing from high potential to low potential. Okay. Now, we should understand some basic terms to go further. To understand the fundamentals of electrical safety, it's good to have an idea about this measuring units and etc. We know electricity, voltage, it is measured in volts. Then potential difference means potential between 2 points. Then current, it is measured in ampere, and for smaller values it will be measured in milliampere. Then DC current, AC current, resistance, then positive terminal or negative terminal, then phase or neutral, then one more point earth. We will be studying these points one by one. The opposition created for the flow of either water or electric charge is called resistance, and it is, if it is electrical, we measure it in ohms. For a battery, from a battery we are getting DC current or direct current. But for higher capacity loads, DC is not adequate, for which we use AC alternating current, which is generated in Moolam or Mulia or so. For AC current, the direction of flow will be changing in either directions. This change of directions will be 50 times per second, which we call as frequency. So frequency of our AC supply is 50 Hertz. Just I was giving some basics about before entering our safety points. Now, the different stages of journey of electricity are generation, transmission, distribution, utilization, and protection. Today, our topic comes under utilization and protection. For example, we generate electricity in Moolam. It is actually generated in 11 kV, and then it will be stepped up using, you can see a substation here, it will be stepped up there itself. Then it will be transmitted to transmission towers or high towers. We can see such towers nearby our home. Then at substation, see here it is a substation, the supply will be collected, and then again it may be transmitted to some other substations, or from here it can be distributed. See here, to the distribution part. See here it is a distribution transformer. We are getting supply to our houses from such distribution transformers. All of you must have seen such transformers near our houses. In a later slide, we will study little more about the distribution transformer. Then here the whole power system is shown. You can see a distribution transformer here, from where we are getting supply to our house. Then in case of apartment, they will be having their own transformer. See here, generator, the current is generated in 11 kV, then it is transmitted and reaching the distribution transformer. Here is the distribution line shown to get you a clear picture. Here 11 kV line, then LT line, it is service line. Using this service line, we are getting the supply from KCB line. Here, single phase and three phase meters are shown here. If your connection is single phase, there will be 2 wires, phase and neutral, and if it is 3 phase, there will be 4 wires, 3 phases and neutral. And in case see here, it is a sample house wiring shown. Here bulbs, then a fan, switches are shown here. Please note this socket, power socket. Here, as per standard, phase connection should be in the right side and neutral in the left side and earth connection in the top. If you closely look these circles, you can see one thing, one important point, that the earth terminal is having a little higher diameter. It is bigger in size, is it? Now, I shall show another picture. Here it is shown more details. The point to note is that the earth pin, see here, the earth pin is bigger in diameter and a little lengthy. So, when we put this pin into a socket, this earth pin will be coming into contact first before the supplies get connected. So I am telling that earth is having that much importance. Another point to note here is that there must be a control switch from where supply is fed to the socket. These are sample DBs, distribution boards installed inside our house from where all the circuits are distributed. These are MCBs, and you can see one RCD or RCCB here. This is also another DB. Now, earthing. Here the earth electrodes are shown. Actually, the earth electrodes are to be strictly done as per IS Indian Standard 3043/2018. In some of the non-standard cases, simply a GI pipe will be inserted into earth, which can cause accidents and which will be affecting our electrical safety. Okay. Now, you might have seen such a lightning protections in the top of buildings. The protection can safeguard, this protection can safeguard the building during lightning. Lightning current is in the order of kiloampere, not milliampere. Such a high current can damage the building. But through these lightning protections conductors, such higher currents can be bypassed to earth. Thus, the building will be under protection, which means earth is having or earth can carry such a high fault current. So we can utilize this earth for our power system also. Now let us see how we can use an earthed iron box and how it is we are getting protection. And here you can see phase and neutral and earth. Here phase and neutral and earth will be inside the filament. And now see here, through our 3-pin plug, the body of this iron box will be earthed through the 3rd earth pin. While we are using iron box, there can be chances of leakage to the body of this iron box. The body of the iron box can be live while we are using it, but it being earthed through the 3rd pin, when we connect it, the leakage protection such as ELCB or RCCB can happen to be tripped. Suppose if we are not having such a protection device, we can get protection up to a limit, since the earthing and human body paths are in parallel, and thus the fault current that may pass through the human body will be lesser in quantity. See here, this human body path and this earth path will be in parallel, and if there is a fault current, we are getting lesser chance to get the electrocutor because current is passing through this earth. So up to a limit, we will be getting protection. But remember, always RCCB along with earthing will give 100% protection in such a case. I will explain the function of RCCB in a later slide. Now, for an equipment to work, we must apply a voltage across its terminals. So minimum of 2 terminals or wires will be there. If it is DC, DC supply, the terminals will be positive and negative, and if it is AC, phase and neutral will be there. The phase wire is also called as live wire. The word live is having a meaning, which we shall explain in the next pages. In some of the 3-phase equipments, instead of this neutral, the neutral will not be given. Some of the 3-phase equipment, neutral will not be given. 3 phases only will be given. Neutral will not be given. We can see why neutral is not given, and etc. We can see in the future slides. Now, as I told you, it is a distribution transformer. I told you for a single phase connection, phase and neutral wires will be there. This neutral point, actually we are not getting it from either the generating station or the substation. Neutral is we are not getting from anywhere. We are creating this neutral point here in this distribution transformer itself. Let us see how and what for it is created. Here in this transformer, there will be a supply incoming point and supply outgoing point. We call it as input side and the other one output side. The input side is also called as the primary side of the transformer, and the other side is called as the secondary side of the transformer. 11 kV supply will be entering transformer through terminals 1, 2 and 3, or we call these 3 terminals or the phases as R, Y and B. At the primary of the transformer, 11 kV supply is given from the nearby substation. Usually such a transformer will be rated for 11 kV bar 433, 11 kV bar 433 watt. Means if you are giving 11 kV supply in the primary side, we will be getting 433 volt in the secondary side. So that's actually another important point is the same phases R, Y and B will be there at the primary and secondary. At the secondary side, the voltage between 2 phases will be 433. Remember, in the secondary, only 3 phases or 3 wires are there. Let us see how the 4th wire or the neutral is created. See, here the transformer winding is shown. It is opened. The primary winding will be connected in delta, and the secondary winding will be connected in star, just like it is the delta connection and it is the star connection. So in the secondary side, see, it is the secondary side, it is connected in star. In the secondary side, the midpoint of these connections, or we call it as the star point, because this connection is called as star point, star connection, and this is called the star point. And that star point will be earthed, and that earthed star point is taken outward as the 4th wire, and it is called as the neutral. And it is called as the neutral. 1 minute. Here, see here in this diagram, you can see neutral point here, neutral and neutral earthing. Okay. So actually, what is the benefit of creating this neutral and what for? If the star point is effectively earthed, the potential of the neutral will be 0 volts. So actually, we may not get electric shock in normal cases if we are touching this neutral conductor, since we are standing in earth or ground, and the touching point and the foot are in the same potential. But if you are touching the phase conductor, what will happen? We are touching the full voltage and we are standing in earth, so it is dangerous. That is why we call this phase wire as the live conductor, or it is live, means dangerous, but the neutral is not live. So here, by creating the neutral point, we are mainly getting 2 benefits. We are getting 2 benefits because you see here we are getting single phase supply. We can get single phase connection between the neutral and one of the three phases. Thereby, we can operate our single phase loads. We can get the 250 volt or 230 volt. Additionally, so that's one of the benefits of earthing this neutral. Additionally, by this neutral, we can get the earth fault or leakage protections. We can understand this one through the operation of RCCB in the later stage. See, in this diagram, we are operating an iron box through an RCCB. RCCB function like RCCB means a residual current circuit breaker, or we call it as earth leakage circuit breaker. Actually, there is a difference between RCCB and ELCB. I am not going deep into that topic. For this study, I am using both terms intermittently, either RCCB or ELCB. So actually, this RCCB function like a security staff of an apartment. He will be recording all the persons entered in and checking whether they have gone out or not. If there are any more persons to exit from the apartment, this security is the responsible person. Similarly, here in this diagram, it will be checking the inward current. See, it is the phase conductor and it is the neutral conductor. So it will be checking the inward current and outward current. Phase and neutrals are wired through this RCCB. You can see here. There is an internal coil inside this RCCB which will be checking constantly whether this inward current and outward current are equal. Say 1 ampere current is going into the phase wire and returning to the source through the neutral. 1 ampere going in and 1 ampere coming in. If both of the currents are equal, the circuit operation will be stable, means the circuit will be constantly working. Consider due to a fault of this iron box, due to a fault in the iron box, a fault current pass from its body to a human body. You can see here, means due to a fault in this iron box, a fault current is passing through the human body. Consider due to this there is a limit after. See here, actually, this person can withstand only up to 30 milliampere current, because in a human body, heart is the most sensitive part. We will study it later. So here we should get the protection for 30 milliampere, or I can say this RCCB is rated for 30 milliampere. When there is a difference of 30 milliampere current in between this phase and neutral, the RCCB will get tripped and the person will be safe. Here you please note that the fault current passing through the person is returning to the source. See here, it is returning to the source or the transformer through earth to the earth neutral. So for proper functioning of RCCB, effective neutral earthing is a must. Also, please note that if the neutral point is, if this neutral point is loosely connected, instead of the zero potential in neutral, you will be getting a voltage. It may have some voltage. In our house connection, usually we can check it by measuring the voltage in between this neutral and earth. Usually it will be in between, it can be from 2 volt or 5 volt, or even 1 volt it can be that. If it is beyond these limits, complaint should be registered to KCB. It can be happened either through improper or loose contact of this neutral earthing, and or even our earthing of our house is not proper, it can be happened. So these things are, there are various reasons for this neutral earth voltage. And another thing, you must note that if this neutral is loose, your equipments will be getting higher voltage. That is also another disadvantage. If there is higher voltage, suppose say it is 350 or 400 volt, you must complain to a KCB, and it is because of the loose neutral earthing. See here, you can see a coil here. And this coil is checking the currents from the phase and neutral constantly. If there is a difference, this coil will be sensing it and the circuit will be tripped. My voice is clear? Hello?
Very clear, very clear, very clear.
1 minute, 1 minute. See, here you can see a bird sitting without shock while it was sitting in a line alone. But when it moved its body, it is touching both of the lines and which can cause electric shock. Means if there is a potential difference between two parts of the body, it will be getting electrocuted or a current will be flowing through and that bird's body. So I am giving the word potential difference. Due to potential difference, a current can be flowing through the, suppose even if it is human or if it is bird, if a potential difference is created between two parts of the body, current will be flowing. Here I am showing you a human body. Actually, our human body is very dangerous when we discuss about electrical safety. The human body is composed largely of water, about 70% is water, and has very low resistance. Near to skin, it is salty in nature, which can pass electricity very easily. For a normal person, the resistance in between two hands or 2 feet is 1500 ohms. But if it is wet or moist, the body resistance could be as low as 300 ohms. And if there is some break in the skin, that will be creating a zero resistance and high current will be passing to skin. So that is what is skin. Now let us think about heart of the body. Actually, you know, in most of the fatal accidents, in 99% cases, current will be passing through the heart of the body, and then only it is becoming fatal. What is heart? Actually, heart means it is a blood pump. It is working just like a water pump. It is working constantly from an electricity or small electricity generated from our body itself. So it is a blood pump working from the electricity generated in our body. So when another supply or electric current is passing through that heart, what will happen? It will be, or its rhythm will be destroyed. Or actually in medical term, it is ventricular fibrillation. That operation will be mostly spoiled. So here I have shown some data to understand about this ventricular fibrillation, etc. 100 joule is enough to start a heart or to stop a heart. Means that 100 joule is enough to start a stopped heart also. Then about 1000 joule can blow our entire body. Then about this, we will study some step potential and touch potential later, and these are the 50 volt. I will explain later that it is the threshold voltage that can create damage to our body. Then about 10 ampere regarding regardless of voltage. Means another question I want to ask you is which is dangerous, whether it is voltage or current, which is creating accident. We shall explain later that. So 10 ampere current, regardless of voltage, no, voltage is not a matter, should be treated as hazard. In normal conditions, 30 milliampere current is the threshold value to create ventricular fibrillation. I explained ventricular fibrillation. Now, see here how we can get electric shock. See here, it is actually